clarify. These are 50 numbers. They are ages of people who moved to Phoenix in 2012 from outside the state. They want us to build a frequency table with 6 classes. That means 6 pieces, 6 intervals. We are going to divide these numbers in 6 intervals. The first thing we have to do is find the size of the interval or the class width. How big is going to be each interval. Then, in order to do that, we have to identify the maximum number, that in this case is 80, and the minimum, that in this case is 18. We are going to subtract them, 80 minus 18, and divide by the number of classes that we want to build. Then that is going to be 10.33. We always round up in order to cover the whole range of data. Then in this case, we round up to 11. Then the class width is going to be 11. The minimum is 18, then we are going to start in 18. Let's say that here we have the class, and we start in 18. We add the class width, that is 11, then we go 29, 40, plus 11, 51, 62, plus 11, 73. These are called the lower limits of the intervals. They start in these numbers. Now, in order to find the upper limit, you just look at that the intervals, they don't overlap. I have to go to 28 because the next interval starts at 29, the one overlapping. Here we go to 39 because the next interval begins at 40, and I don't want to overlap, etc. Here, 61, 72, and 83. Those are my classes or intervals. Now there is something that is called the midpoint. Midpoint. That is the number that is exactly in the middle of the class. But in order to find that number, one of the ways is add the two limits and divide by 2. Then if we add 18 plus 28, we get 46. That divided by 2 is 23. Sometimes this thing doesn't want to work. Now, with the midpoint in the next interval, we have 29 plus 39. That is going to be 68. Divided by 2 is going to be 34. And then we do the next one. And then the next one, 67. And then 78. Those are the midpoints. They represent each class. Sometimes they are used to graph. Instead of using the whole interval, we use only the midpoint and graph the frequencies. Now, frequencies are the next step. Let's put FQ. Frequencies. What are we going to do? We are going to go to our data and count how many numbers are between 18 and 28. Those are the people between 18 and 28 years old. Then we are going to count them. Then we need to go back to our PowerPoint. How many numbers are between 18 and 29? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nothing else. 10. Then that is the way you find the frequency. You come here and look how many numbers between 18 and 29, the first interval. Let's go to the whiteboard again. Then here we are going to write 10. And the same for the other classes. No, we count how many numbers between 29 and 39, etc. I have here an Excel file that has the classes, the midpoints, and the frequencies. Then here in the frequency column, if I pick a number, for example, I am talking about the 7, then what is a statement that I can say? I can say 7 of the people are between the ages of 62 and 72. Now, there is something that is called the relative frequency. It's kind of the same, but in different units, because it's going to be the same 10, but in percentage. First of all, when you add these numbers, you have to get 50 because we were counting the numbers in the table. Then if we add these numbers, we have to get 50. If we don't get 50, it's because we didn't count in the right way, and then we have to go back and correct. Now, then we need to know what part of 50 is 10, what percentage of 50 is 10. In order to do that, we can do 10 divided by 50. And that is the 20%. It's going to be 20%. Now we can drag this down because I already have a formula there, and those are the percentages. And again, if we add this, we have to get 1 because this is the 100%. If you want to write this in percentage, you can multiply by 100 everything, but this is okay. How can I write? How can I read, for example, the 18? I can say 18% of the people who moved to Phoenix from other states are between 40 and 50 years old. That is the meaning of that 18%. Now, the cumulative frequency uses the frequency, but adds up the frequencies. Then starting in 10, at the 18, that is 28, at the 9, that is gonna be 37, plus 40 is gonna be 41, plus 7 is gonna be 48, plus 2 is gonna be 50. Has 20 and 50 also. And then how can I read one of these numbers? Let's pick the 28. I can say that 28 people in my data, they have ages that are 39 or less, because we add these two first number of the two first intervals. That means people that is 39 years old or less. How many? 28 of them. Now, Excel graph, make a graph of your data. That is really a frequency table also, just like a graph. Then the thing we are gonna do, and this you need to know it, is highlight the data, because probably you are gonna have to graph your data. Then you need to know that command. Then insert, and then let's see, because this is in the middle of my way. Let's see if I can move it. Oh. Then nothing, I can move it up and see what happens. Here in the middle, you have this bar graph. Then you click there. This says histogram. Then you click there, and this is the histogram. Okay, let's move it here by this side. You can see Excel makes this default graph, has 5 classes. We can double click here in the intervals, and then change maybe the bin width. Then we know that the width of the interval was 11, and see what happens. There is no universal way to build a frequency table or a histogram. All the software, they have a different way to do it. Every single statistic book has a different way to build a frequency table. I am using this way because this is our book and they talk about that in the homework. I am following your book, our book. If you can see, they build here the intervals differently because they go to 29, and here the interval is closing 29, and then in the next one is opening 29. Then they avoid the overlapping that way. Now, if we graph a curve on top of the histogram, say something like this. Trying to go like this. We see that there is kind of a tail in the right side, no? Some histograms, they look like this. A bar here, then one that is higher, and then another one that is higher, and then they get like symmetric in both sides. And then if you draw the curve looks like a bell shape. Bell shape. It's also called a normal distribution. And it looks like a bell shape is called also a normal distribution. But our graph has a tail in the right side, and that is called skewed to the right. Right here is skewed to the right. Sometimes they are skewed to the left. Something like this. The tail is in the left side. Or sometimes they look like a little kind of constant. Like this, and this, and this, and this, then kind of constant here. And this is called a uniform distribution. But the distribution refers to the shape of the histogram, how the data behaves. Then you know that most of the data is at the beginning. You see, there is more data at the beginning than at the end. Close to the beginning of the data. There is a graph that is called the polygon, the frequency polygon. Let's see if I can erase this. And the frequency polygon is graph with the midpoints. The midpoints are going to be here in the middle of each interval. Like here, for example, here in the middle, here in the middle, here in the middle. But the heights are the same because it's the frequency. No? Then the same frequency with the midpoints. Then you get 1 point that is here, 1 point that is here, 1 point that is here, etc. And then you join those points with lines, then you get something like this. But usually you don't have the histogram there. No, I have the histogram here because it's easier for me, but usually you don't have the histogram. And then you prolong, and then here you prolong also. That is called the polygon, the frequency polygon. And then it's made with the points. Be careful, make sure that your graph starts, the y-axis start in 0, Otherwise, it's gonna be deceiving because it's gonna be out of proportion, disproportionate. If the y-axis doesn't start in 0, then be aware of that.